let's get started. I know some of you aren't quite finished yet, but that's okay. All right, so number one, add the fractions. Who wants to do this one? We've been doing this for such a long time, so I'm sure a lot of you are good with this, but let's keep practicing, right? So 9/5 plus 2/7. Who wants to do this one? Anyone? Let's see. Kaden, do you want to do number one?
Sure.
Sure. Thank you. I'll just do it in the bottom right hand corner since there isn't much space.
Okay. Once you write it down, then you multiply it, and then the number next to it.
Right. So
Then you multiply the top and the bottom number, basically. Then you multiply it like this. I'm gonna need this. Let's go now. Yes, then the bottom zone is 45.
Yep, very good.
Top is 63 and 10. It's 72.25.
Very good, right? So you see Kaden first made a common denominator, right? 35, which is 5 times 7, and then 7 times 5, right? And then we multiply the numerators by the same number we multiply by the denominators, right? And then we can finally just add up the two new fractions that we created to get our final answer. Okay, very good. Number two. Who wants to do number two? Alan, you want to try number two?
So -6 times -3 would be 18. And then that times -2 times -1 would be that would be 2. So then 18 times 2 would be 36.
Very good. So I think that's a good way to do it, right? So Alan split it up into two parts. He first did -6 times -3, and he gets 18. Does anyone know how we get 18 here, right? We have two negative signs, so two of the same signs. So then that returns us a positive number. And the same goes for -2 times -1, right? So this will also give us a positive number in 2, right? And then we finally multiply these two together. So 18 times 2 equals 36. So are we all good with this one? Thumbs up. Okay, good. So number 3, Claire, how about you? Did you get number 3?
I don't know how you do. I know what's 3 minus -2.
Do you have any ideas? Do you have any guesses, maybe?
I think maybe is it's 1. I think.
Not quite, right? So remember, when two signs are the same, we add, right? We have a negative sign here and a negative sign here. So we just add like 3 plus 2.
5.
There you go, 5, right? And then keep
5.
going. Do you think you can keep going?
And then -5 minus 6. So I think it's 11.
Good guess, but it's actually -11, right? So it's the signs are there are a lot of signs going on, but it's really confusing. So it's the signs between the numbers that you have to consider, right? So 3 and 2, you see that the signs are in between are the same. But if for -5 minus 6, you can kind of think it's as +6, right? So the signs are in between are different, so we have to subtract it. So it's -5 minus 6 is -11. So let me put this together, right? So -5 plus -11. What do you think that is?
-16.
16 or
-16.
close, but it's -6, right? So it'll be -16 equals -5 plus -1. But this time we have a +5, and then we subtract 11 from that, right? So I guess you can kind of think of it the number line here. We have maybe 5 here, and then we go back 5, going back 5, subtracting 5, so that would give us 0, and then we have to subtract another 6, right? So that'll bring us to -6. Okay, so this one's a bit tricky, right? But that's how we do know that one. So number 4, Angela, do you have any ideas on how to do number 4?
Number 4, like I'm kind of confused on it.
All right, so for these word
What
problems,
is it?
yeah, we should always draw this out, right? So let's just have 3 books, maybe one. So these are not, this is not a very good drawing, but so the first book is 1.7, and another is 2.4. So this one we don't know. The last one we don't know, but we know that all of them together is 6.3. So do you have any ideas on how we should approach this problem? How can we find the question mark? Charlotte, how about you? Do you have any ideas? Any guesses? Okay, Angela just left the meeting. Okay, all right, so Kaden just told me in the chat. First do 17 plus 1.7 plus 2.4, which gives us 4.1, right? So we know that these two books here together are 2.1 or 4.1, sorry. And we know that the entire stack is 6.3, so we just do 6.3 minus 4.1. Remember, line up the decimal point, and we get 2.2 as our final answer. And it's not 2.2, it's 2.2 inches, right? Inches. So I said, don't forget the units, right? Don't forget units. All right, very good. Okay, so last one, number 5, algebra. Who wants to do this one? This one's tricky, all right? So any volunteers? Let's see, Alan, do you want to do number 5? I guess Kaden again. So I guess I'll explain number 5 then, since none of you want to do this one. So you remember we have to isolate the variable, right? So we want to get x by itself, like so x equals something, right? So and then that will return us the answer. So how can we move all the rest of the numbers to the other side? So first we can get rid of the -3, right? So how can we eliminate this? We can add 3 to both sides, right? Remember, what you do on one side, you have to do to the other. So -3 plus 3, we all know that's 0, right? So we can just cross this out now. So we get 5x equals 15, right? It's because we do the same thing on both sides. So now, does anyone have any ideas on what we should do to finish this problem? We need to get rid of this 5 next to the x, right? So in this case, we can divide both sides by 5, right? So we can divide, so divide by 5 here and divide by 5 here. And we get x equals 3. So this one's a bit tricky. I think we should go over this a bit more today. So let's get into that then. So isolating the variable, right? So we're going to come back to this slide and do more practice on isolating the variable. Okay, clear all. Okay, let's try, start simple, right? So x minus 4 equals 3. So we need to get x by itself, right? So how can we get rid of this 4? How can we get rid of the 4? Claire, do you have any ideas on how we can get rid of the 4?
Um, uh, I don't know, but I think you, you just add 4 on both sides.
Very good, right? So we add 4 on both sides because we know that negative 4 plus 4 will just give us 0. So that'll give us x plus 0 equals 7. And we know that 0 is nothing, so we don't even have to really write it. So just x equals 7, right? So that's how we solve for x in this equation. Very good. So great. Now let's do another one. So x plus 7 equals 11. Kaden, how are you? What do you think we should do here? Using algebra, how can we find the answer?
I don't know.
You don't know any ideas? We need to get rid of the
I
7.
think we should put the 7 down and put the 7 over there.
Could you repeat that?
I think put 7 next to 11.
Yeah, so how can we get rid of this? So we have a positive 7 here. So how can we get rid of this?
I don't know.
You don't know? Let's see. Angela, how about you? Do you have any ideas?
Mm, I I personally don't know.
Don't know. Right, so remember, so we want to make this a 0, right? And we want to make this x plus 0 to make it an x, right? So we want to get rid of the 7 on the left side. So to this, we must find the opposite. I think that might be a better way to put it. We must find the opposite. So we know that the opposite of 7, positive 7, is negative 7, right? So we must subtract 7 on both sides, right? That way we can cancel out the 7s. But remember, we must do the same thing on the other side. So 11 minus 7 on this side. So we get x equals 4 as our final answer, right? So we want to find the opposite, right? So let's say we have x minus 3 equals 5. Yeah, exactly. 7 plus 4 equals 1. But we must do this algebraically so we can make sure our answer is correct 100% of the time. All right. So in this case, we have x minus 3. So in that case, we need to find the opposite of negative 3, which is positive 3, right? So we add 3 on both sides, right? So add 3 here and add 3 here. It's not 2, it's 8, right? So we get x equals 8 here, right? Add 3 to get rid of the negative, the minus 3, and we must do the same on the other side. So x equals 8. So another one, x plus 2 equals 1. So again, so this time we have a positive 2, so we must subtract 2 on both sides, right? So that we're taking the opposite. You have a positive 2 here, and you must subtract, so basically a negative 2 here. So plus 2 minus 2, this will give us 0, and this will be x equals 1 minus 2, right? 1 minus 2, be careful here, right? It should give us a negative 1, remember, right? We flip it around, and then we add a negative sign to the front, so it's x equals negative 1. Very good. All right, so now I want you all to try this, right? I want you all to try this and tell me the answer in the chat. So we have x plus 9 equals 13. So what is the answer here? What is x? So once you're done, let me know in the chat. So how can we get rid of the 9 on the left side? We need to find the opposite, right? So we have x plus 9 here. So how can we get rid of it? 13, right? X plus 9 equals 13. Claire, double check your answer. Double check your answer. Very close. I want everyone to give it a try. Even though you might not get it wrong the first, or not, you might not get it right the first time. It's always just practice, right? The more practice you do, the better you'll get at it. So good, right? So solve this, we need to subtract 9, right? So subtract 9 and subtract 9, which leaves us with x equals 4. Very good, right? Does everyone get how we do this? Can I see a thumbs up from everyone if you understand what we're doing here? Thank you. And for those with their camera off, if you could raise your Zoom hands, that would also be appreciated. If you don't want to turn your camera on. Okay, so now let's try another one, right? So let's do x minus 5 equals 2. So what should the answer be here? Can check again. You have to really be careful here, right? So we want to. So what should we do to get rid of the 5? Right. So what should we do to get rid of 5? Yeah. Okay, and check again. Oh wow, both of you said -3, which is interesting. Oops. 2 of you have said -3. Does that work though? If we put it -3 back in the equation, we get -3 minus 5, and this actually gives us -8, right? So this does not work. So remember, we have to solve this algebraically, right? We need to solve this algebraically. So how can we get rid of 5? We need to think of what is the opposite of -5, right? So we have a -5 here. What is the opposite of -5? 5, good, right? So we must add 5 on both sides. Do we all understand why we're doing this? We must add 5 on both sides. This we would get rid of -5 and +5, and we would get x equals 7, right? It should be x equals 7. 7 minus 5 is 2, right? So that makes sense. So does everyone see what we did here? So we don't want to guess, right? Guessing is sometimes it's useful, but in this case, we don't have to guess, right? We can just use algebra and solve it this way. Okay, good. Let's try another one. How about let's do 2x equals 4. So what should we get here? So this one's different now. We now have, instead of doing subtraction and addition, we must do something different, right? It's 2x, not like x plus 2 or something like that. So this is multiplication, right? When we see a number and a variable next to each other, this means multiply. So this is the same thing as 2 times x. Remember the example I gave you with burgers, right? The hamburgers, each burger costs $3, and then we have 3x, and we can put in any number of hamburgers, and that would give us the price, right? Right. If we have like 4 hamburgers, that'll give us 3 times 4, which is 12, and that'll be the price of the total number, the price of all the hamburgers together, right? So this means multiply 2 times x. Okay, good. So the answer here is 2. Claire, how'd you get 2? Oops, I didn't mean to erase that. You got the answer right, but how did you get it? Can you explain how you got the answer?
So So 2x equals 4. That is 2, and 2 a number equals 4. So it's 2 times something equals 4, and 2 times 2 is 4.
Good. Okay, that does make sense. But if I give you like a big number like 57x equals 3654, you cannot really guess here, right? But or guess it, right?
And I don't know the algebra way for this.
Okay, it's okay. We'll go over this right now, right? So we must isolate the variable, right? That means keep x to one side. So we must get rid of this 2 here, right? We want to get rid of it. So how can we do that? We can this time we can divide by 2 on both sides, right? So we can divide by 2 and divide by 2. And why does this work, right? So remember, let's say we have 3 divided by 3. We all know this is 1, right? So anything divided by itself is 1. 1 million divided by 1 million is still 1, right? So anything divided by itself is 1. So in that case, we can use that knowledge and apply it here, right? So we know that 2 divided by 2 is 1, and any number multiplied by 1 is just itself, right? So we have 2 times 1, and that'll give us 2, right? X times 1, x, let's use the dot here. Remember, dot means multiply, and we don't really want to get confused by writing 2 x's right next to each other. So x dot 1, which is multiply, will also give us x, right? It's just itself. Number times 1 will always be itself, right? So in this case, we are able to divide by 4 or divide by 2, sorry, on both sides, right? 2 divided by 2 and 4 divided by 2. Remember, we must do the same thing on both sides. And this will give us x equals 4 divided by 2, which is just 2. So does everyone see how we did it using algebra? Do you see what we're doing here? Okay, very nice. Okay, so let's do more, right? So let's do 3x equals 27. So what should the answer be here? You do it using algebra, right? I know all of you can figure this out really easily, but Alan, your hands up. What do you have?
You divide it by 3.
Good, right? So we must divide by 3, right? To get rid of the 3 on the left. And what's 27 divided by 3?
9.
9, right? So that's how we do this one, right? You have to really watch out here. Sometimes you have 3 plus x. Sometimes you have 3x. So you really have to watch out whether we should divide or whether we should subtract or add, right? So you really have to pay attention. And some of you may be wondering, is the variable always on the left side? No, sometimes it can be on the right side. So let's say we have x plus 5 equals 8. So how can we find x in this case? It's the same thing, right? We just need to keep the x on one side, right? It can be on any side. So x equals something here. So put the answers in the chat. If you, oops, I just deleted it. Sorry, I didn't mean to. X equals x plus 5. What do you think we should do here, right? We should try to keep the x on to one side. So what do you guys think is the answer here in this case? Any guesses? Remember, we want to get rid of the 5, right? Because it's next to the x, and we want x to be by itself. So we have a positive 5 here, and we need to figure out what the opposite is, which is -5, or a -5 or subtract 5, right? So we must do the same thing on both sides, and we get 3 equals x, right? So it's the same thing. So if it's on either side, so don't get confused, all right? Okay. Let's do a couple more. 6x equals 30. So what should we do here? How can we find what x is? Good. So the answer is 5. X equals 5. So how did you get that? How do we get x equals 5? Kaden, how did you get x equals 5?
Oh, you're talking to me?
Yeah. You got the
So
answer.
I just did this. And just see how many 6 plus 5 is 5.
Exactly, right? We divide by 6 on both sides because that would give us 1x, which is the same thing as x, right? Remember, 1x is the same thing as 1 times x, and anything multiplied by itself is the same thing, right? So it will just equal x. X, 30 divided by 6, all of you know this, it's 5. Okay, very good. Alrighty. Now let's do some combination, right? Combination. So let's say we have 3x equal, 3x minus 2 equals 10. Some of you may see this and want to do divide by 3 first, but that would complicate things because we have 2 terms on the side, so we must also divide by 3 here. And that would just create a mess. All right, so in this case, we should do this one first and then work on the number next to x. So give this a try. This is pretty difficult, but I want y'all to just try this and see if you can figure it out. All right. Remember, we need to get x onto one side. What should we do? Three x minus 2 equals 10. So I guess the way to think of this is if you want to put in a word problem, you buy hamburgers for $3 each, and then at the register, you get a $2 discount, and your total comes out to $10. So how many hamburgers did you buy? So that's kind of a way to think about this, you know. The thing with algebra equations is once you get an answer, you can always just put it back in and see if it makes sense, right? So if you put 3 into x, we get 3 times 3, which is 9, right? And 9 minus 2 does not equal 10, so that answer does not make sense. So you can always double check and see if your answer works in these cases. The 3 is very close. All right, Alan, do you have any ideas on how we should approach this problem? Okay. All right, so I'll give you guys the first step, right? So I'll give you guys the first step. So we have a 3x minus 2, right? So the opposite of negative 2 will be plus 2 in this case, right? So we have plus 2 here. We must do the same thing on the other side. So plus 2 here. So this gets rid of the negative 2. So we have one less problem to deal with. And then once we simplify everything, we'll get 3x equals 12. So now, is this problem a bit easier? So can we figure out how to find x given this new equation? Right, so we first did the first part, and now we are able to make this equation a bit easier. So remember, we want to get rid of the 3. So how can we get rid of 3? we can divide by 3, right? So dividing by 3 on both sides, and that will leave us with x equals 4. Okay, there you go, right? Does this all make sense to you guys? We must add 2 first to get rid of these, and we'll make it easier, and then we have 3x equals 12. Okay, good. I kind of want to try this word problem, but it is a bit, it might be a bit too difficult, but let's give it a try, I guess. So algebra word problems number 1. So Emily went to Staples to buy school supplies. She first bought a pack of markers that cost X amount of money. So word problems, right? That's another thing that we'll be going over this week. Word problems. So with word problems, you really have to read the problem carefully and find out what information is important, right? So X amount of money. So we'll just write that down for now. So this was markers. Markers. Okay. So she then bought a backpack for $22. So backpack is $22. And then the backpack was $10 more than 3 times the price of the marker. So there's a lot to unpack here. So the backpack was $10 more than 3 times the price of the marker. So we know that the price of the markers is X. So we could say 3 times the pack of the markers, which would be 3x. Right? So 3x would be 3 times the price of the marker. So does everyone understand why we made it 3x, right? 3 times the price of the markers. And then the backpack was $10 more than that, so we add 10. And then we finally equate that to 22, right? So we need to set up an equation first to solve it. So the backpack was $10 more, right? $10 more, so plus 10, then 3 times the price of the markers. So we set x equals markers earlier, right? So x equals the markers, 3 times that plus 10 equals 22. So then now how can we solve for x? We need to find the cost of the markers. So what can we do here? Claire, any ideas? What do you think we can do here?
Do 22 minus 10.
22 minus 10. Very good, right? So we subtract 10 on both sides, right? Is that what you said?
Yeah.
Okay, very nice. So as you can see here, we find the opposite of positive 10, which is negative 10. In this case, this will just cancel out, and 22 minus 10 is 12. So we get 3x equals 12. We just got this again. So this would be again. So finally, we divide by 3 on both sides, right? To isolate x. 12 divided by 3, you all know that. So x equals 4. And we want to use some units, so $4. We'll just put a dollar sign. So very good. So can I see a thumbs up, sideways thumb on this question? Okay, very good. All right. And so this one's a bit difficult because we have to figure out how to set it up first, and that I think is pretty hard. All right, let's move on to our second word problem. Oops. Yeah, okay, that's correct. Okay. Who wants to read this? Does anyone want to read the problem? I guess I'll read it then. All right. Kevin has $25 saved up in his piggy bank. So let's write that down. That's important information. So $25 in piggy bank. Okay. He wants to buy a book that costs $9. Maybe it's Harry Potter, right? Let's buy a Harry Potter book for $9 and then spend the rest of his money buying toy cars, right? Toy cars that cost $2 each. So how many toy cars can he buy? So that one's a bit tricky. So first, someone tell me, what should we set x at? So what is x? I think that's always really important. We need to find out what we're looking for. So what is x? Any ideas here? What should x be? Remember when we did the hamburger problem, it was 3x, and x was how many hamburgers we bought, right? So we always need to know what is x. So what is X?
X is the amount of toy cars.
Exactly, right? So X is the amount of toy cars that he can buy, right? So that's what we were looking for in this case. So X equals number, I'll just use a hashtag or number of toy cars you can buy. So now let's set up our equation. So he has $25. So first, $2 each, right? The toy cars are $2 each, so we must have a 2x, right? But he also wants to buy a book that costs $9. So in this case, we'll add 9 and we'll equate that to 25. So does everyone understand how we set this up? So he has $25 in total. He buys a $9 book and then also has money left over to buy toys cars, right? So and then that will equal to 2x. So 2x plus 9 equals 25 here. So this is the algebraic equation that we've set up from this word problem. Okay, so how can we solve this? Kaden, what did you do in this case? Are you saying something? I can't hear you.
One.
Kaden, you there?
Yeah.
Can you explain what you did? You got the right answer.
Basically, I did 25 minus 9 equals 60. Then I count by 2 straight to 16.
Exactly, right? So very good. So in this case, 20, we must subtract 9 on both sides, right? So that's how Kaden got 16, right? So 2x equals 16. So that's the first step. This is a two-step problem. So the first step was to subtract the 9 on both sides and get 2x equals 16. This is how much money he has left over. I'm sorry. After he buys the book, right? So he buys the book that costs $9 with $25 savings. So he has $16 left sitting in his piggy bank that he can spend on cars. So now we divide it both sides by 2, right? We need to isolate x, and we get x equals 8 as our final answer. And we should use units. Every time we do a word problem, there should be units. So x equals, again, the number of toy cars. All right, 8 toys. Okay, very good. All right. So before we get into number 3, let's go over a little bit of a rule that we have for variables. So someone take a guess. What should x plus x equal? Any ideas? X plus x. What should this equal? We've added variables with regular numbers before, but now we are adding a variable onto a variable. So what do you guys think x plus x should be?
2x?
2x, very good, right? So this is kind of just adding normal numbers, right? So we can, so maybe we have, let's say, for as an example, we have 3 plus 3. And all of you know this is 6, right? But you can also write this as 2 times 3, right? I'll use the dot for multiplication because I don't want you guys getting confused. Dot for multiplication, right? So this is also equal to 2 times 3. So as you can see here, these two are pretty much identical except that the x is replacing the 3, right? So does anyone see what we're doing here? So let's do another one. How about 3x plus 2x plus 5x? What do you guys think this is? Just let me know in the chat once you have, or just take a guess if you don't really know, but 3x plus 2x plus 5x. What do you guys think? Okay. Just take a guess. It's okay if you're not right the first time, but I want you all to just guess what this thing is. 3x plus 2x plus 5x. What do you guys think? So if you're confused, you can always think guess of a number, right? So let's say we plug in 1. So we have 3 times 1 plus 2 times 1 plus 5 times 1. So this will give us 10, right? So 3 times 1 is 3, 2 times 1 is 2, and 5 times 1 is 5.
Yeah.
So the final answer we'll get in this case is 10x, right? So very good job to those who got it, right? Right, so we just add up the, these are called coefficients, the numbers that go in front of the variable. So we just add those up like normal and we get 10x. Just do another one. So let's say we have 5x minus 3x plus x. What do you guys think this is? 5x minus 3x plus x. What do you guys think? All right, good. So this should be 3x. So 5x minus 3x will give us 2x. And 2x plus x. Remember, x by itself is kind of the same. There's just 1x, right? So 2x or x and 1x are the same thing, right? So they're equal. So this will give us 3x as our answer. Very good. So now let's get into another word problem. Our final one for the day, I guess. So here is the algebra word problem number 3. So we have Robbie, Bobby, and Dobby enjoy collecting baseball cards. Robbie has 3 Michael Jordan cards. Bobby has 5 Michael Jordan cards, and Dobby has 6 Michael Jordan cards. They decided to sell all of their Michael Jordan cards to their friend Tobby for $98 in total. And assuming that Michael Jordan cards are identical in design and price, how much does one Michael Jordan card cost? So what should our X be? So what are we trying to find? Oftentimes this will just be given as in the form of a question, right? So what do you guys think? What should X equal in this case? Let me think back to the hamburgers, right, that we went over last week. 3x equals p, right, where p is the price and 3 is for $3 per hamburger. So x in that case was the number of hamburgers that we bought. But in this case, we have to look at the problem and it's asking us how much does one Michael Jordan card cost? So that's what we're looking for, the price of one MJ card. I'll just shorten Michael Jordan to MJ card. Right, so that is X. That is what we're trying to look for, the price of one Michael Jordan card. Now let's set up the equation, right? So Robbie has 3 Michael Jordan cards, so that'll be 3x. Bobby has 5 Michael Jordan cards. And finally, Dobby has 6 Michael Jordan cards. And that gives us a total of 98. Okay, so what do you guys think? How can we solve this problem? Remember, when we have 3x, when we have a bunch of these x's added together, we can combine these all into one form, right? So what is 3x plus 5x plus 6x?
14x.
Very good, right? So we can just add up the coefficients. Remember, that's the fancy term for the number in front of the variable. That gives us 14x, right? 14x equals 98. So this one's a bit complicated of a division problem, but maybe you guys figure out what x could be. In this case, 14x equals 98. So this is, you may need to do a bit of division or guess and check in this case, Okay, very good. So x equals 7, right? So 14 times 7, remember, if you need to double check, 4 times 7 is 28. Put 8 here, put the 2 here, I guess. 7 times 1 is 7, plus 2, and that'll give us 98. So we see that 7 is the correct answer here in this case. And again, we need to use, remember units. Units are very important word problems. So we have $7. Okay, very good. Yep, very good. So good job. So this is rather expensive for a bath for a card, but I've heard that some rare cards can even go up to like $50,000. So who knows? So yeah, so that is how we do this problem here. So word problems are very tricky. You have to set up the equation and then just figure out what we're looking for, right? I think that's the most important thing. And maybe if we go back to the warm-up question, like let's take a look at number 4, right? Because this is a word problem. So maybe we can set, because what we're looking for is the thickness of the third book. So we can set that as x, right? Equals third book thickness. I ran out of space. So I'll just write on a separate line. So we know that one book is 1.7 inches thick. We know the second is 2.4 inches thick, and the third one we don't know, so we'll just put it as x. And then finally we get 6.3 on the right side because that's the total amount of books. And again, we want to isolate x onto one side. So we add 1.7 plus 2 plus 4, so that gives 4.1 plus x equals 6.3. And all of you know how at this point on how to isolate x. We just subtract 4.1 on both sides. And we get the same answer as before, right? X equals 2.2. So that's why algebra is so useful. You can use it to solve a variety of problems. And yeah, so I hope today's class was pretty interesting because we did go over some fun word problems, right? And we learned how to set up algebraic equations. So it is 3 o'clock, and that is all we have for today. I will be sending you guys a short homework with some more algebra word problems. So you have to figure out what x is and then how to set up the entire equation. So now it's time for the intermediate class. So thank you all for coming, and I'll be seeing you guys on Wednesday. All right. So thank you, everyone. Bye-bye. That's a lot of ease. Bye. Okay. Zachary, I'll make you host now.
Yep, thanks. Bye, everyone.
Bye.